When beginners think about cybersecurity, they often jump straight to threats and defenses, but in operational technology, OT, one of the most powerful safety and security moves is much quieter, knowing what you actually have. Asset management is the discipline of identifying, describing, and maintaining an accurate picture of the systems that exist, what they do, and how they are connected. Without that picture, almost every security decision becomes guesswork. You cannot confidently segment networks if you do not know which devices need to communicate. You cannot prioritize patching or compensating controls if you do not know which systems are exposed and critical. You cannot respond calmly to an incident if you cannot tell whether a device is expected, whether a change is normal, or whether a piece of equipment is missing. Asset management in OT is also different from typical office IT because the environment includes controllers, sensors, human-machine interfaces, engineering workstations, network infrastructure, safety systems, and sometimes specialized vendor appliances that do not behave like ordinary computers. Many of these assets have long life cycles, limited logging, and strict uptime requirements, which changes how you discover them and how you maintain records. This lesson is about turning asset management into a real operational practice through discovery, creation, validation, and maintenance, rather than treating inventory as a one-time spreadsheet exercise. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Inventory discovery is the process of finding assets that exist in the environment, including assets that are obvious and assets that are hidden or forgotten. In OT, discovery can be challenging because some devices do not respond well to aggressive scanning and because some segments are isolated or tightly controlled. Beginners sometimes assume discovery is simply running a tool and collecting results, but discovery in OT often begins with multiple sources of truth that must be reconciled. You may have network diagrams, vendor lists, procurement records, maintenance tickets, and physical walkthrough observations, and each source might be incomplete or outdated. Discovery is therefore both a technical and a human process. Technical discovery might include observing network traffic to infer devices and communication patterns, while human discovery might include identifying cabinets, panels, and devices during site walkthroughs. A critical beginner lesson is that discovery is not about perfection on day one. It is about building a repeatable method to reduce unknowns over time. Unknown assets are a serious risk because they can be unpatched, unmanaged, or even malicious devices introduced without authorization. The goal is to shrink the unknown space until the environment is explainable. Creation is what happens after discovery, when you take what you found and turn it into an inventory record that is consistent, usable, and meaningful for operations and security. Beginners sometimes think creation is just typing names into a list, but a good inventory record is more like a profile of an asset. It includes a stable identity, such as a unique identifier, and it includes descriptive information that helps you understand the asset's role in the process. In OT, creation also includes defining how you will name assets, how you will categorize them, and what attributes matter most. For example, an engineering workstation might be categorized differently than an operator interface system because the workstation can change control logic, while the operator interface typically displays and interacts with the process. Network infrastructure might be categorized as a boundary-enforcing asset because it shapes segmentation and visibility. Creation also includes capturing the relationships that matter, such as which devices talk to which controllers, which workstations program which systems, and which vendor tools are involved. The reason creation matters is that raw discovery data is often messy, and messy data cannot support confident decisions. A consistent inventory is the foundation of safe policy, safe monitoring, and safe incident response. Validation is the step that many organizations skip, and it is the step that determines whether an inventory becomes a trusted operational tool or a dusty document. Validation means confirming that inventory records match reality and that the reality you are observing is still what you think it is. In OT, validation is essential because environments drift over time. A device might be moved, replaced, reconfigured, or temporarily bypassed during maintenance, and those changes can quietly become permanent. Beginners should understand that validation is also what catches the gaps between different sources of truth. A network diagram might show a device in one location, but a walkthrough might reveal it was relocated. A procurement record might show a model number that differs from what is installed. A maintenance ticket might show a replacement that never made it into the inventory. Validation also supports security detection because an asset inventory can be used to identify anomalies. If you see a device communicating on an OT segment that is not in inventory, that is a potential unknown asset that deserves investigation. If a known asset suddenly shows a different identity or communication pattern, that could indicate misconfiguration or compromise. Validation makes the inventory dynamic and trustworthy, which is what allows it to support decisions instead of just existing as documentation. Maintenance is the ongoing practice of keeping the inventory accurate as the environment changes, and it is the part that turns asset management from a project into a program. Beginners often assume inventory is something you build once and then have, but in OT, change is constant, even if it is slower than in IT. Firmware updates, component replacements, network redesigns, vendor support activities, and new instrumentation projects all create changes that must be reflected in inventory if the inventory is to remain useful. Maintenance includes updating records when assets are added or removed, tracking ownership and responsibility, and ensuring that changes are reviewed and approved when necessary. It also includes periodic reconciliation, where you compare what you observe in the environment to what the inventory says and investigate discrepancies. A strong maintenance process often ties inventory updates to operational workflows, such as requiring that any change ticket includes an inventory update step. This is not bureaucracy for its own sake. It is how you preserve trust in the inventory. In OT, trust is everything because decisions affect safety and reliability. If people stop trusting the inventory, they stop using it, and then the organization loses one of its most powerful resilience tools. Asset management becomes truly operational when it supports daily decisions, and that means the inventory must be designed for real use cases rather than for abstract completeness. One use case is risk prioritization, knowing which assets are most critical so you can focus protections and monitoring where consequences are highest. Another use case is segmentation planning, knowing which devices must communicate and which should never communicate, so firewall rules and network boundaries can be designed safely. Another use case is incident response, quickly identifying which systems might be affected when an alert occurs and deciding whether to isolate, monitor, or escalate. Another use case is maintenance planning, knowing what firmware versions exist, what vendor support contracts apply, and what replacement parts are compatible. Beginners should see that a good inventory reduces downtime because it reduces time spent searching and guessing. It also reduces security risk because it reduces blind spots and makes anomalies stand out. When an organization uses the inventory actively, inventory quality tends to improve because people notice errors and correct them. When an organization treats inventory as a compliance artifact, inventory quality tends to degrade because nobody relies on it. Operationalization is therefore partly about making the inventory central to work rather than peripheral. There are also common pitfalls that beginners should learn early so they can avoid building an inventory that looks impressive but fails in practice. One pitfall is treating an asset inventory as only a list of devices without capturing relationships and dependencies. In OT, relationships matter because a device's risk is influenced by what it can reach and what depends on it. Another pitfall is creating records without consistent naming and categorization, which makes searching and reporting difficult. Another pitfall is failing to define ownership, so nobody feels responsible for keeping records current. Another pitfall is collecting too many attributes that are hard to maintain, which creates a maintenance burden that overwhelms the team and causes data to become stale. A better approach is to start with the attributes that support the most important decisions and then expand thoughtfully. Beginners should also understand that asset discovery methods can have risks, especially if active scanning disrupts sensitive devices. That is why discovery must be done carefully and often begins with passive observation and physical verification. The goal is to improve visibility without introducing new operational risk. Asset management in OT is a balance between completeness and safety. Another important concept is that asset management supports security controls indirectly by making the environment more predictable, and predictability is a powerful security advantage. If you know which devices exist and what they should do, you can define what normal communication looks like and then detect deviations. If you know which systems are authorized to program controllers, you can monitor and audit those pathways more effectively. If you know which remote access methods are approved for vendor support, you can detect and question unusual sessions. Predictability also helps with resilience because it makes recovery more controlled. If you need to rebuild a server, an accurate inventory tells you what it is, what it connects to, and what configuration it should have. Without that information, recovery becomes improvisation, and improvisation is risky in OT. Beginners often think of security as reactive, but asset management is proactive because it strengthens the foundation that makes all other controls more effective. It also helps communication across teams because a shared inventory becomes a shared language. When operators, engineers, and security staff talk about the same asset identifiers and the same categories, misunderstandings decrease. That alignment reduces the friction that can otherwise slow response. Asset management also has a strong connection to criticality and compartmentalization because you cannot protect what you cannot classify. If you do not know which assets are safety-related, you cannot ensure they are isolated and tightly controlled. If you do not know which assets are shared services, you cannot assess their blast radius if compromised. If you do not know which assets are legacy and unpatchable, you cannot plan compensating controls like stricter segmentation or enhanced monitoring. A mature asset management program, therefore, includes not only what is it, but also how important is it and what are its constraints. Beginners should see that this information enables smarter architecture. Instead of guessing, you can design compartments around high-criticality assets and define controlled conduits for necessary communication. You can also prioritize observability, focusing on boundary points and high-consequence pathways. Over time, asset management becomes the spine of your security program because it connects governance, operations, and technical controls. It also supports audits and compliance, but the most important value is operational. It helps the organization run safely in a complex environment. When you bring discovery, creation, validation, and maintenance together, you get a cycle that makes asset management sustainable. Discovery reduces unknowns by finding what exists. Creation turns findings into consistent records that support decisions. Validation keeps those records aligned with reality and catches drift and anomalies. Maintenance ensures that change does not quietly destroy inventory accuracy over time. This cycle is not a one-time project. It is an ongoing operational practice that improves security and resilience steadily. For new learners, the most important takeaway is that asset management is not busy work. It is the foundation of everything that follows. Without it, you are defending a landscape you cannot see, and you will always be one surprise away from confusion. With it, you can design segmentation safely, monitor effectively, prioritize realistically, and respond calmly when incidents occur. In OT, where the consequences are physical and the tolerance for disruption is low, that calm, informed capability is one of the most valuable outcomes you can achieve.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.